I'm having some cold.
Okay, so welcome to the benchmarking Node.js team meeting for September 10th, 2019. We'll sort of follow our agenda. We don't have too much on it, but I guess, and we were having a conversation on compression and some of the work that we've done, so I think we'll add that to the agenda. But first, like, any announcements that people want to share in general before we get started?
Not I.
Nope. Okay, so let's get back to that. I'll just give a little context for people who are watching the recording. Udom had mentioned that his team had been doing some work on some additional NPM modules to do compression, and I just mentioned that we'd done some experimentation at IBM to see if we could modify core Node.js so you could specify a shared library which would provide an alternate lib library to do compression. We just hadn't gotten enough cycles to do the benchmarking to show that when it was off, it was an acceptable overhead. So we were talking a little bit about that. I think Gabriel, you had something you wanted to add it when we were about to start.
Just one thing. So in the fast use case, right? I agree that constantly that having like an indirection on every call into deflate is a penalty. But there is even in fast there should be a break-even point, because after all, you called the function so as to compress stuff. So if the actual payload code that does the actual compression is much faster, then at some point it offsets the overhead. So there is a point at which you could have just used regular zlib and gotten, or the built-in zlib, and gotten the same performance as you do by paying the overhead and then doing the faster zlib. Past that point, it's always better to use the faster zlib. However, you quickly approach the point where the function is taking too long. So there's that. So there may be like a non-zero window between the break-even point and the end of the useful lifetime of the function that is a performance benefit that's worth paying indirection for.
See, I'm not personally so worried about whether when you turn it on it makes sense in all cases, because some cases it won't, and you just don't turn it on. My bigger worry was that when you integrate it into the code base, so like what Udom has now is like a separate library that you can use or not use, but you got to change your code to use it, right? What I wanted to see if we could do was like integrate it directly into Node. So on the command line, you would say, use this shared library instead, but that will add some overhead. And what's important is that we be able to show that hopefully that actually the overhead that's there is small enough that it doesn't matter.
Yeah.
If it's too big, people are going to say, well, no, we shouldn't include it because it's going to hurt people and we can't actually turn that off, right? Yeah.
At the very least, or in the ideal case, we would be providing people with an additional knob that they can turn.
Right.
And for some people, it may make sense to turn that towards an external zlib.
Yeah, that's what we had. Like what we'd experimented was with like a command line that says, use this library. If you don't, the default is you don't specify that. And internal to Node itself, it basically had a check that says, when you made a call to any one of the zlib calls, it says, did you enable this? No, just call exactly what it would have called before. But that does require an if and a call.
Yes, right? It does. Yeah.
And so, the hope would be that if you're actually compressing something, that's non-zero work, right?
Mm-hmm.
Yeah, exactly. That's right. Yes.
So,
yes.
Hopefully compression is enough of a piece of work that a call overhead is not actually that significant.
Yeah, and especially a decision overhead. If it's just as simple as a single decision, then it should be all right. Because at that point it's pretty cut and dried, right? Because yes, you pay only for the decision, and then the fact that it's an indirection after the decision has already been made is part of the performance of the library. You can just bundle that in with the performance of the actual compression. The price of the indirection.
Yeah, because I can't remember. I'll have to go look at the code. I can't remember if I don't think we used an indirection table because that basically means you always have an indirection, right?
Exactly. Yes. Yes. You don't want to do that. Yes.
Yeah.
You
So I
want
don't
you
think
want
we
to
did that.
Yeah. Yeah.
I think we just added the if that says, if on, go over here, otherwise
Yeah.
just continue on the way you were going.
Exactly. Yes.
Yeah.
Yes. So then you've confined the overhead to the case where the flag is on, plus the price of checking the flag.
Exactly. Yeah.
The Michael, so when you added this library, is it compile time you specify the information?
No, it's basically runtime. It's like a dash dash zlib lib, you say equals to this, and it's a shared library. So if you specified that,
Yeah.
it'll dynamically load it, and
Okay.
look up all the pointers you need to do the indirections or to do the forwarding, basically.
Okay. So another thing to consider, if I mean, performance is definitely one thing. Another thing to consider is the security because of this dynamically sharing with some library. How do
Yes.
you how do you make sure that it is doing the right thing and not, because now you can link with any library, right? As long as there's an API there, you can
Right,
link with any
but you
intelligence
have to
library.
tell it on the command line that this is the one I want to use.
Hmm.
Yeah.
Right, and I
So
think depending on your environment, you can point that to a place where only you have access to write a library, right?
yeah.
So
I mean, we already load lots of code. I mean, once the node process is up and running, it is assumed to be secure. So security is pretty much deferred to the administrator at this point.
no, but currently all the libraries are statically linked in the binary, right? In node binary, there is no
Yes.
shared library except the system libraries. But all the like zlib, everything is now we
Yeah.
are static linking with the binary, right? So that kind of opens that vector, right, for the security opening.
Um, it
But that's the next part.
so there are options you can build that do dynamic linking. The objections I've heard in the past is that you don't want to look for a library and automatically load it if it exists in a standard place.
Mm-hmm.
Yeah,
Because
exactly. Yeah, because that could be anything.
then people can basically without the person who's running the code add the library and it'll run without and be used without them knowing. As specifying the library path on the command line, I think addresses that, in that if I can change your command line, I can run pretty much any code I want anyway.
Yeah, yeah.
Right. And who provides it? So think about in fast environment, when you upload the function, normally you specify what node. Let's example is a JavaScript code. You say, this is where my node, this is the version of node I want to use, and this is my function to run. Now,
Yeah.
now you have additional component to upload where my library is going to be. Who provides that library?
Yeah, so that kind of case, it might be that you're out of luck.
Okay.
Unless
Yeah.
the fast infrastructure says, well, one of the options I want to give you is faster
Yeah.
compression, and then
And I think you can
specify some
customize
FAS
this.
option.
Like you can, like certain providers, they allow you to customize the environment, right, in which your function runs, like ahead of time, right? Like you can have like an execution environment, and you can specify I want this and this and this, right? So like you said,
Right.
but I'm not sure how much granularity you have over that, you know. Also, another thing I just thought about is, since we're talking about the dynamic library, we could potentially render this as an add-on, right? Because add-ons are dynamic libraries too. It's just here's an add-on. It's got some symbols. Here's the symbol table. Go run with it, you know. And then we, instead of having a command line, we would be using the require mechanism to load the library. But otherwise, it would be the same. You load the library, and then you pass off the function pointers to Node core. And you're basically telling Node core, here's a bunch of function pointers. They satisfy this particular use case.
Right.
Use those, not the ones you would normally use, and thereby you turn on the indirection.
Yeah, that's true. I think when we looked at the other one, it'd be interesting to think all through this. I think you're right there. What I think in our case, we had like an existing zlib library, So, and I think there are existing zlib libraries. So it's in some cases, you just don't want to have to even write a wrapper, right? You just want to be able to
Oh, for sure. Yeah,
point to an
absolutely.
existing library.
Yeah. The reason why I brought this up is that in the FAS case, you may not have control over the Node.js command line,
Right.
but the FAS infrastructure may support loading native add-ons, because that's a fairly popular sort of thing to do with Node.js, right? In which
Yep.
case, if you cannot control the command line, you could still tell Node.js to use this particular binary at runtime, but you would use a JavaScript interface to pass it.
Right.
And again, the security would be at least as secure as loading a native add-on of any kind, which
Right.
has security implications, as we all know, but people still
Right.
do that. So this would just be another add-on in that sense.
Do the FAS environments have compilers generally installed?
I don't know.
That would be the one wrinkle is. The other thing, like for me, is some of them are interesting. Like it's also sometimes it's going to be tied to the hardware, so it's not purely a software thing. You need a card, or you need some co-accelerator.
Right.
Like in the case that Uno mentioned, you need to probably have a certain level of the instruction set available, right?
Yeah. Well, I mean, but that could all be checked, right? I mean, we're talking about the native add-on, right? The native add-on can actually check these things because it has fairly low-level access, and the native add-on could short circuit.
All of it that checks any additional checks you have, it adds the instruction and the time spent. So there's an overhead. What I'm talking about is anytime you add, you can make it as sophisticated as possible, all secure and everything.
Okay,
but that
we're talking
adds overhead for the short-lived function, and that's one use case which is growing exponentially now with in the JavaScript world, in the Node.js world. Right?
Okay, but let me ask you this: for compression in particular, how short-lived can you be before it's useless?
Well, look at all the micro benchmarks, all the input we have for the compression. They're so small. None of them are realistic, right? They're like what, 10 bytes, 15 bytes, I mean not even 1K bytes. It's just running n number of time, but the input itself is very, very short, very small.
Okay, but what is it in real life? Like, how do people use compression in FAS? What are the chunks that they are sending?
As a function, so think about this as a function. So what is going to impact? It probably will not impact the execution of the function. What is going to impact the startup time, which is nothing but the node core startup time. So now that node core startup time takes, let's say, take 30 milliseconds, is going to take 40 milliseconds, or maybe 50 milliseconds.
Right. But if you add 20 milliseconds to the startup time, but you double the throughput from I don't know, from 10 megabytes per second to 20 megabytes per second after you've paid that price, it may still be worth it, right? Because the function can run for multiple seconds and it can do a lot of compression in that time, right? So that's why I'm asking, how much compression do you do in a FAS environment with a single execution of the function? How long does that function run after the whole thing starts up?
The FAS itself is meant to be run for the very, very short-lived. So you are not supposed to run huge function, right? Not like a web server application. Think about very, very small. Think about anagram, or think about imagery.
No, okay, I get that. Okay, but then what can you accomplish in such a short time with compression? What can you compress, like a PNG image, or what sort of realistic use case is there for running a compression algorithm for 30 milliseconds?
So what I was trying, my point was that it's not that there are no use cases. What my point is that there will be increase in the startup time and the node runtime. So when we think about the node performance, we are not thinking about the compression algorithm itself, right? We are talking about the Node.js runtime startup time, and that will be can we make it small enough so it is not impacting the startup time? We already, I think, current or with latest version, we have a 30 millisecond startup time on our Xeon hardware, right? Our goal right now is to get it to 10 millisecond. If that is the goal, and if we add this code, are we going to achieve that goal or not achieve that? And again, this has nothing to do with the actual compression or crypto or anything else, right? Yeah.
Okay, but since we're talking about compression, right? if you look at the picture from the end user's perspective, right? They can compress, let's say they can compress 200K in 20 milliseconds with the infrastructure as it is now, startup time and everything. You call the function, it's a cold start, you send it 200K, it takes 20 milliseconds to compress, and then you get it back, right? Now, if we can make a change so that in those 20 milliseconds you can compress 300K, right? Even though the startup time is much greater, it's a much greater proportion of that. It's still, from the end user's perspective, okay, I've sent 300K, it's taken just as long, right? And I got it back. Okay, it's 1.5 times faster. I don't care that the startup time is now a greater proportion of the total time spent running the function. It's still 1.5 times faster from their perspective.
Yeah, so think about now case where we are not doing a function, not doing compression, but now there is this some code is going to get executed as part of the startup time, which is nothing to do with the compression
Right.
itself.
Okay.
Right?
Yeah. Okay. So you
So,
don't want. Okay. You want
yeah,
the
so
you
you
want
don't
to
want
take
to
the
slow
code.
down the case which not using the compression. You
Okay,
want
but then if you do this as an add-on, then you're not slowing down the case when you're not using the compression, because it's an add-on. Only those functions which require it will actually be slowed down by it. Similarly, with Michael's interface, only those functions which have the command line parameter will be slowed down by it.
who's
So
going to
those
do who's going to do require node core.
uh, require is part of the function definition. You call require this super fast zlib and then deflate.
Yeah, so what I was saying that who's going to call, so in typical application, the user application calls the require. In Node core,
Yeah.
if you take away the zlib and put it external library, as we were talking about, then someone needs to do a require, right? Maybe it is
Yeah.
depending on some command line options, but there is that code which going to check for the command line options.
Well, the difference too is that, like, I think Gabriel was suggesting a require, but the require may actually be too late. Like
Yeah.
a command line option can be early enough. Now, it may not matter. You may be able to switch engines further along.
Yeah. Almost certainly, right? I mean, think about it. Think about Node zlib, right? Let's say you have, just for simplicity's sake, you have a global static pointer to deflate, right?
Yeah.
It's set to null. Normally, it's set to null, right? So you basically say if global static deflate equal null, then deflate, right? And that's the flag check price you're paying no matter what, right? But if it's not null, then star global static deflate, right?
Yep.
So then you're paying the price of loading the library and indirecting because it's not statically linked and all that, right? But that's what it looks like from the deflate perspective. You're only paying that price if that pointer is not null. Okay, otherwise you're paying a really tiny price of comparing something to 0, right? It's like one more instruction, right? Compare that global. Okay, I'm sorry, not one more instruction, because you have to fetch it, put it in the processor, then compare it, and then get the result. But it's only like, it can't be more than like 10 instructions to check whether that global static value is null or not. Now, how that global static value becomes non-null, we have several design choices. It either becomes non-null by virtue of the fact that something was specified on the command line and the price of loading the library was paid before the first call to deflate was ever made, or a require was present in the definition of the function, which caused us to set that value to something non-null by some as yet undefined Node.js API. But either way, the result is the same. It's now non-null, and therefore you use that instead of using the statically linked deflate. But you only do that if the customer said do that, right? Otherwise, Node core, the only addition in Node core, the only impact is those 10 instructions to compare that pointer to null. I mean, we could even say, this is probably wrong, but we could even say, like, if likely equals null, then
Oh
go
no,
with
we
this.
probably want to do something like that. Yeah.
So because for most use cases it's going to be null. So therefore you want to wrap it in likely to help out the
Yeah.
branch predictor or whoever gets helped out.
Exactly. We want to make it as cheap as possible if you haven't turned it on.
Exactly. That's right. So we can even wrap that check in an if likely. And then it's up to those who are heavy users of compression to decide whether paying the price of the additional startup time, of the additional indirection during each call is worth it for them. And we can run the experiment to decide whether after we add all this there are any use cases left for whom it makes sense. Because I can't imagine that it will never make sense, right? Because if you're compressing anything significant, your function is going to run for at least 300 milliseconds, right? To compress anything useful in this world, right? And so okay, instead of the 30 millisecond startup time, within those 300 milliseconds, it's going to be a 50 millisecond startup time, right? Plus 250 milliseconds of useful work, right? But that's still 250 milliseconds of hardware accelerated work, whereas before you had 270 milliseconds of software work, right? So you can still achieve at least a couple of X there. I can't imagine not. But anyway, we'd have to run the experiment.
Yeah.
So, Michael, you have a volunteer here, looks like.
Yeah, okay. So basically, yeah, I mean, I'll dig up what we had. I don't know if it probably won't apply to it won't apply to Node, but I can dig that up. And then, the real work I think is, doing the experiments to say, can we show that it's not a big overhead?
Yeah.
And then, getting it landed and stuff. Because I think as long as we can show the case where we truly don't believe the overhead is going to be a problem, it unlocks a bunch of opportunities for people to do things where it's not like you have to change your code. It's like, okay, you've got some existing code, even HTTP, which I think does some compression and decompression right behind the scenes, would benefit.
Yeah. Oh, for sure. Yeah, HTTP is a huge candidate for zlib. Yeah. And I think the bigger picture here is also that more and more of these common infrastructure components like compression and hashing and these kinds of things, they are becoming increasingly hardware accelerated, and some of the paradigms that we've been using so far, which is pretty much to run these things in sync and to use a thread if it becomes too heavy for the main thread. This is going to change because hardware can have its own threading. Hardware can be implicitly asynchronous, right?
Mm-hmm.
So and so you get asynchrony without having to do your own threading and so forth. And like with like when you have like what is that called, SIMD, right? Single instruction multiple data. Uh, that is also implicitly streamed, right? Because you have no benefit if you're doing it synchronously, because you're feeding exactly one data and then asking for the result, right? And so the concept whereby you have streams that run in parallel has to go much deeper into the stack than it has so far, right? So far, streaming has been an abstraction imposed upon what is otherwise a synchronous algorithm. But now the algorithm itself becomes asynchronous and able to accept multiple streams implicitly without any sort of abstraction on top. So this has to be woven deeper and deeper into the stack, right? And add to this the fact that there are different kinds of hardware. Like you can do compression with FPGA, you can do compression with GPU. All of these have their own libraries, some of which you may only get the benefit from if you expose the streaming interface rather than the synchronous interface. So
right.
so sooner or later, we'll need to accommodate this increasingly heterogeneous sort of computing landscape, where you can have acceleration for domain specific applications.
Right. And that's certainly why we were looking at this. Was we already had hardware which had acceleration for zlib, and it's like, how do we make it useful for people using Node without having to change your code, right? So
yeah, exactly.
I mean, my current work with our ICEL library, what I try to do, keep the JavaScript API very much similar to how the Node.js really provides. and
Right.
underlying, but using the npm install mechanism, and it's very easy to integrate that way for sure if you have a use case like that. So as long as you keep that JavaScript API same, then underlying you can add any library.
Right. So
At
that's
the same
probably
time,
good as
yeah.
long as you're the one calling zlib, right? If you have any dependencies or anything that are using it, it'll be
Uh,
harder to get them to use your library versus the
Yeah, for sure. Yeah, 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 exactly. Yeah, so
uh,
yeah, you're right. This only applies to the calling project. Yeah.
yeah, and so one good thing about it's explicitly mentioning that way is one good thing is even if in the fast world, okay, if you take the same code into the fast world, you can then specify when you're selecting either a machine or infrastructure, you can specify the type of hardware you want to run this function on, because I'm using this specific npm install
right.
package which takes
Yep.
advantage of certain type of hardware.
Yeah, no, you could definitely, yeah. So you could, it does give you good flexibility. It's just the how you get people to use it challenge sometimes.
Mm.
Yeah.
It's just a marketing. You need to kind of promote that,
Right.
the people know
Yeah.
about it in the sea of npm packages for
Right.
sure.
Okay,
Yeah.
so that sounds good. I think we've got, I'll dig up the code, and then it sounds like Gabriel, you're interested in. I'll loop you two in, because where we stalled out was doing the benchmarking, which is how this all relates back to this group is we sort of stalled out on doing the benchmarking that would help us show that it wasn't, that it was okay to land it.
Mm.
But
Okay, now before we give up on this topic, or before we move on from this topic, if you do provide that code so I can look at it, will I have the hardware on which to actually test it? Because
no,
if I do this on my laptop, it'll just fall back.
no.
So it will basically serve as like a proof of concept, like an inspiration, basically, for how to swap out zlib on the fly.
It should, yeah. Like I'll have to, it's been a couple years,
Okay.
but the goal was that you could specify any one of several zlib libraries.
Okay. Good. Okay. Yeah. So yeah.
You might have to write a little wrapper or whatever, but basically it should be like, it was meant to be pretty much compatible with the standard zlib libraries that are out there. So I think there were already ones that were provided for Intel hardware accelerators. Like I think there were some cards that Intel had. So you might have some existing zlib libraries that you could actually test it out with as well.
Yeah. Okay.
I mean,
Sounds
in the simplest case, we could basically make one which wraps the existing zlib that's used in Node, right? So
yeah.
effectively offloaded, and you can just test that. It won't be any faster. In fact, it'll be a little slower.
Yeah. Oh, and I mean, I can always test like system zlib. I mean, we
Yeah.
already kind of have that, but we have it at build time rather than runtime.
Right. Yeah, we could test it. Exactly. We could test that one. Where I really thought the initial testing would be is not convincing you can make it faster, but convincing that, yeah, when you don't turn it on, there's just no problem.
Yeah. It's not much. Yeah. There's no penalty. Yeah.
Because I think as long as you show that case and then you say there is hardware that can be beneficial to our customers at particular times, I think people aren't going to say, oh, well, don't do that. Convince me you really can have a benefit.
Or acceptable overhead, I think.
Yeah, as long as the overhead's acceptable. Now, internally, it's very good to be able to say, here's a tangible use case that's accelerated by 4 times, right?
Mm.
So if we could come up with that too, that'd be great. But I got to just plug in here. Okay, so it might take me a little bit of time, but I'll dig that stuff up and we can start a discussion on that.
Sounds like fun.
Yeah. Okay, the other thing on the agenda was 225, which is investigate time taken, number of benchmarks in core.
Yeah.
Just gonna open that.
Yeah, I have a spreadsheet about that I shared with you. We were gonna sort of decide which, or help decide, or put it to the community as to which benchmarks are more important, if I remember correctly. It's been a while.
Well, it was around figuring out if there's a smaller set that makes sense for us to run, like we've talked about running it some periodically or once, like, I forget what the intervals we were talking about, but basically trying to have
Yeah.
some subset which could run, or even, you know, collect data so that you could go back and look at it when you needed to.
Yeah. So, what do you think? Have you had a chance to look at the spreadsheet? I'm not sure if I shared it correctly.
Where is it? Yeah, is it something you can paste into the issue?
Yeah, it's a Google spreadsheet, but only you and Utam have access to it for now, which is why I didn't paste it into the issue, because it wouldn't be very useful to anybody else. So you should have like an invitation to edit.
When did you send that out?
Let me see here. Well, I don't know, because it sent it from the interface, but I can send it again as a link. So let's
Oh,
see.
maybe we can add that link into the issue itself so that it's, you
Yeah,
know.
but it's not public. That's the thing,
I
because
think that's okay. I would just paste it in there anyway, so that we know where it is. And then if somebody wants access, if somebody clicks on it and says, "Hey, I want access," it shows interest, and we can give them
yeah,
access.
okay, sure, yeah. Yeah, and give them permission. Yeah, okay,
Exactly.
yeah, that's a good point. Okay, let's do that then. Okay, 225, you said.
Yep. Here, I can paste the link in the chat if that helps.
Okay, yes, please. Chat. Yes, that's the one. Okay. We'll see. Where are we? Too many desktops. There we go. Okay. Yes. And yeah, of course. Yeah, I hit paste, and of course I'm pasting the link to the issue.
Yep.
Okay. 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 So basically, like, please vote. Well, okay. Okay. So spreadsheet tracking. Relative importance of benchmarks. Okay, so it's going to be pretty terse and cryptic for now, because I
Sure.
kind of wanted to run the spreadsheet by you to see if this is the structure we want for it. Yeah, so there you are.
Right. Okay.
So yeah, this is basically it, and you know, I was actually thinking of Chalker's, you know, TSC meeting
Yep.
spreadsheet, do something similar, you know, because, you know, and
I
then
might not call it votes, but I might call it like used or something. Like, because what I'm thinking is, what we want is like, which ones do people use actively?
yeah,
Because those would probably be a good subset to have, right?
yeah, for sure.
So it could be like, can you mark, you know, try and get as many people to fill out, have you used this or not? The only question, like, this isn't a huge list. Like, I'm wondering, well, it's a pretty big list, isn't it? I'm wondering if we should try and do like a Survey Monkey survey or something.
Oh yeah, okay, yeah.
Because that'll total up numbers for us a lot more easily, right?
Yeah. That's a good point. Yeah, I mean, I've never done one of those surveys. I can certainly start. Yeah, and I guess they aggregate for you and stuff.
Yeah, like you would basically get a results that say, you know, 20 people said yes to this one, 5 to this one, 2 to that one, and so on.
Yeah, because otherwise this is an exhaustive list as of master. So
right.
People should see their benchmarks here, if ever they use them. There's even one that isn't yet on master. It's the one for the weak refs. Where's Nappy? Because, you know, I'm working on that weak references as cleanup hooks. So I even have a benchmark here. That's not really a benchmark yet. But anyway, I can remove that line. Yeah. So okay. So then I can turn this into a Survey Monkey survey and go from there, if I figure out how to do that, because having never done.
Yeah, I was gonna say, we can, if that's easy, it might be easier to just do that. We can also ask the foundation to help us, because they do have an account to do some surveys.
Oh, cool. The other question I have is, so like the voting system that we should use. I mean, I know this is super splitting hairs, but should I just make like a set of checkboxes and then people check the ones they like, or should I do like a score, like from 1 to 10 or whatever, because I think you can do that. Or you can do like agree, disagree, or somewhat agree, all that stuff.
The first, I mean, is there? I mean, the thing that popped into my head was like, have you used or run this yourself?
Right. So
right,
like
yeah, it would just be
a single bit basically.
Yeah.
Okay. Yeah, then that's going to be a tally for each benchmark.
Right.
And maybe we can specify the use in the functional use versus also the performance use. Does people use it for the functionality and not really care so much about the performance of that? Um, but the feature of that function, things like that.
Right.
So
Okay.
that can also give us some direction, which are the really people care the performance functions and the performance of a particular
Right.
API. And also on top of that, I was thinking, looking at that list, can we narrow down ourselves something which is just a JavaScript function? They are really, you do require, but then mostly it is just a running in V8 mode. You're not really using any of the Node.js functionality, right? And the performance of JavaScript is easy to gauge from how the V8 performance is, the newer versions. But there are certain APIs, for example, Zlib, Crypto, which depends on certain libraries, which they don't really have. It's not easy to go and test the performance with those libraries. You have to build yourself and kind of test the performance. Maybe it is possible those we can combine with the Node.js specific. Maybe it's event loop related, maybe it's a zlib related, and things like that. So there is a
Well, if you
clear
look at the
distinction.
bottom, like 231, 232, and 233 are zlib specific tests.
Yeah, so something which you cannot really, people cannot really know the performance immediately. They have to go build their own thing and then maybe run their API and build some small application to know the performance of deflate, for example.
But my understanding was, and correct me if I'm wrong, that you know, people who use these benchmarks, who've ever needed for a very good reason to run these benchmarks, they should already be aware of these performance implications. Otherwise, they wouldn't be running benchmarks, right? And
No,
it is those
that's not what I was
you're
saying.
asking, right?
What I was thinking more of so Node.js, how you use Node.js, you use for the something which V8 doesn't give, right? Like a file system access,
Yeah, yeah,
HTTP
yeah.
access,
True.
HTTP to
But that's all these
yeah,
should be Node APIs. They don't
yeah,
test generic JavaScript.
Yeah,
yeah,
pretty much the only ones that are not, I think, are assert, deep equal, these kinds of things.
yeah. So deep equal doesn't it use Java? It's pure JavaScript, right?
Yeah,
I
yeah, yeah.
suspect no, but I suspect those are things we've implemented in Node.
Okay.
Oh, yeah. But
Yeah, like
they
these are things where we've written code in Node. If it's in the V8, it's we don't necessarily have coverage for those.
Well, deep equal buffer for sure. That would probably be native at some point.
Yeah, I think they all are.
The for each,
Really?
for example, there's one for each. Is it native to Node or the is it V8 specific or the JavaScript specific?
A
Where's
buffer
that one for?
cluster crypto.
So I'm thinking that is there a way we can narrow it down further to make
So
it
okay, the ES
Pretty
ones.
much.
I think those we might have introduced specially at some point, just because I don't know if there's any 4-inch code. I mean,
Yeah.
so other than the ES ones, then maybe I would say what I said is true.
Yeah, I don't know. What about events? Events is an abstraction, right? Or is that also native back?
Right, but I think that's like Node events that are implemented at the Node level.
Oh yeah, okay. Well, FS is a given. Yeah, I mean, I guess there's very little.
The specific ES ones may have been added because at some point when we float patches, like we don't necessarily have an exact copy of V8. So I think those may have gone in because we actually did break things at some point on some key things.
I see. Okay.
Yeah. I guess they have their value, and we'll find out to how many people.
Right.
Yeah,
It'll be interesting to how many people say they run each of these or have run them right in the past. It's kind of like I think we should say it's like, have you ever run these You know, which of
Yeah.
these
So okay. Now,
run
now
when
that's an important consideration. How shall we phrase this? Because that's
right.
very important, right? Because
Yeah.
the votes will be influenced by how we phrase this.
Yeah.
So shall it be like, which of these benchmarks have you found useful in the past, or
I think my first question might be just, which of these benchmarks have you ever run when, you know, writing a PR, writing/testing a PR?
okay?
Then separately, we could have a second question, which is like, which of these do you think are most important to test? Like, I guess the problem is that when you change code, maybe that's not a good question, because like, obviously if you change the URL, something related to URLs, you should run the URL ones, right?
Yeah. Yeah, they're all kind of important, but still there could be some bias towards one or the other, and this would uncover that bias, you know.
Right, like how many times have you used them is a good one, because that is a bias in terms of like how many people actually need to run a particular subset, right?
Oh yeah, wait. Yeah, how many times have you used the given? Have you used the benchmarks below what in the previous year, or like, because you know, how many times have you used? I mean, we should give a window.
In the last year, say.
Yeah.
You
Yeah.
can
Okay.
even have like two questions: last year or last ever.
Well, I don't know. It may be lost in the mists of memory, but
Yeah,
people will
I think
definitely
last
have a
year, like
feeling.
if you haven't used it in the last year, you don't use it all that often, right?
Right. Exactly. Yeah. So okay, just okay. One thing that I just realized is, with each of these questions, each of these questions has as a constant factor the length of the list of benchmarks.
Yeah,
So
so that's why, like, I
it
wouldn't
gets
want to have
it
too
gets
many
long
questions,
fast.
right?
Okay. So which of these are okay? So then that's a checkbox. Which of these do you think are most important? That's the checkbox. Or we could do like a most important, least important thing. At that point, we can do like a 1 to 5 thing. How many times have you used? Oh, this might be okay. This is also probably going to be a 1 to 5 thing, like very often, sometimes, never, that kind of thing.
Right.
Because I don't think we'll want people filling out like integer validating text boxes, because that's just going to take them forever.
No, like, I think I mean, even we might just ask the one question: which of these have you used?
Yeah. Yeah, because I guess they're probably very important if they've been used. They have some importance, so that sort of speaks to the second question. And I mean, the first question is a special case of the third question, right? You use them for what purpose, right? Writing, testing a PR. So yeah, I guess the third question seems to be the one that sort of captures the most.
Yeah, just have you used
And
them
then,
or not? Which ones have you used? And because like that might be the simplest, and people can just check blah 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 blah. There we go, right?
well, I mean, we can set the default to never. Like, how many times
Right,
have you used
exactly. Yep.
default never, and then they'll just upvote the ones that they actually
True.
used. And
Yeah, no, that's true. And then you could have the sometimes, often, whatever. That would be good.
yeah, exactly. Okay,
I
all
gotta
right.
drop off because
So
it's 3 o'clock. But
okay, all right. So I will hold this one. Okay, cool. All right. So yeah, I'll try to turn this into a survey, and then we'll go from there.
okay, sounds good. So I'm gonna say in the notes here, Gabriel shared survey. Discussed next step. Gabriel's will refine. Okay. I guess, Udom, can you PR in the minutes?
Yes, I can do that.
You might add a little bit more detail or that you can remember, but otherwise.
Yeah, I can do that.
Okay, thanks. So I got to run. Talk to you
All right.
both later.
Thank you.
Talk to you later.
Talk to you
Bye.
later.
Bye.
Bye.